Well then, how about a long-duration X-class solar flare and another earthly directed coronal mass ejection, or at least one that includes an earthly directed component? We'll talk about it and lots more here on the Daily Space Weather. Exciting stuff going on. You may have heard about an X-class solar flare. I'll bet you've heard about it already. I'll bet you haven't seen coverage like this. This is only 3 hours, by the way. That is 2200 yesterday evening through 1 o'clock Universal Time this morning. That X-class event did indeed generate a massive coronal mass ejection, which is expected to brush past Earth, so not a direct hit. Some ejecta may indeed strike Earth's magnetosphere. Our videos normally show 30 frames per second. We slowed these down to 15 frames per second, again, because it's only showing 3 hours. And where do you see the solar flare section of this video? This is just the intro, folks. You ain't seen nothing yet from this video or this channel, as we are barely even getting started. So let's show some 24-hour videos since this is the daily space weather. By the way, those initial videos that we showed were 131 plus 304 angstroms. This is 304 plus 171 angstroms. Oh, check it out. It looks like there's a separate event coming from right down here. It actually occurred after that initial CME. So there's actually 2 events going on there. And so that can affect things. We'll do a further analysis of that here momentarily. Here's another 24-hour video for you. Zoomed in on the equator. And no major changes coming in sunspots in the past 24 hours. How you like them apples? Let us know in the comments what you think of that spectacular solar imagery. Oh, what's that? You want even more? All right. I guess we can accommodate that. There is an extreme close-up for you, for your viewing pleasure. Another 24-hour video featuring ionized helium and ionized iron. Yowzers. By the way, we were planning on doing a cosmic ray report today. We will have to postpone that until tomorrow's daily space weather video. By the way, if you haven't checked out the merch shop, you may find the merch shop. We envision conversations going like this. Oh, hi, I see you're wearing a mask. Is that because you're sick? No. What? Then what are you doing? Anyway, if you're sick, stay home. You may be in public with one of those things on your face. I'm sure there's a reason for it. Let us know in the comments if you miss the days when you would expect a guy to pull out an AK-47 from behind the counter if you entered a convenience store with your face covered. Links to the merch shop on the homepage at smashomash.com, the official homepage of the Smash News Network, least busted name in news. And welcome to the Neo Renaissance. Visit us on social media, click our links, help the channel that way, as we don't exactly get a lot of coverage for the most comprehensive daily space weather content and imagery of the sun you'll find in the known universe. All right, let's switch to the SDO continuum, looking at yesterday plus today here. A little bit of growth with this sunspot group up here and some sudden migration of that southern umbra. A little bit of sunspot decay up here in the northeast. Besides that, again, not a lot going on as far as sunspot activity. So don't get solar flares and coronal mass ejections and sunspots and coronal holes and prominences and filaments. Don't get them all confused, folks. They're all separate phenomena. That's why we cover them in great detail. Because when it comes to science, what you want to do is immerse yourself in the data. And you may end up with answers to questions not asked, which is what's happened to me. It's interesting, to say the least. So anyway, let's go over volcanoes and earthquakes here. Stromboli, there's the Sierra del Fuoco this morning, showing some minor lava flows going on up there. Oh, intense spattering activity. That is not something to be hanging out around. Flying molten rocks. Don't get hit by any. It'll make for a bad day. So, again, it looks like, we've been saying this for days here, it looks like the Fagradalsfjall Fissure Complex is slowing down its effusive eruptions. Seems to have ended or at least been interrupted there. Mount Mayan is producing an unknown ash plume over Luzon Island, Philippines. Ibu producing a 6,000-foot ash plume over Halmahera, Indonesia. The Great Sitkin volcano in the Aleutian Islands of Alaska, producing an effusive eruption and slow-paced viscous lava flows. Sweet. The U.S. is gaining real estate. The Great Sitkin volcano in the Aleutian Islands. Status level remains at orange. Alert status, that is. Fuego, exploding flight level 150. It's a 15,000-foot ash plume. 15,000-foot ash plume over Guatemala. 20,000-foot ash plume over Peru from Sabancaya and Ubinas. We are unable to detect. If it is erupting, please do not pole vault the caldera. Next seismic activity. It is moderate over the past 24 hours. No major quakes, but some interesting ones, such as that North Atlantic, Mid-Atlantic ridge quake. That 5.3 occurred at 14:10 Universal Time yesterday afternoon. We'll cite other quakes of a 5 or greater magnitude. There's a 5.8 at Afghanistan, and that one was at over 200 kilometers depth. So probably didn't do all that much damage for a 5.8 magnitude earthquake in that part of the world, where building codes are not exactly Japan or California. Chile had a 5.1. That was also nearly 100 kilometers estimated depth. The timing of that was 17:38 Universal Time yesterday afternoon. China looks like it took some damage at 18:33 Universal Time because of a 5.4 magnitude quake near the surface at an estimated depth of 10 kilometers. A 5.2 happened there in southwestern Australia. That was at 21:34 Universal Time. The China quake was at 18:33. Afghanistan also had a 5.3. That was at also 209 kilometers estimated depth there at 0:30 this morning. Sulawesi, Indonesia had a 5.2 at 1:44 this morning. The Pacific Antarctic Ridge had a 5.2. It's a lot more earthquakes than we've been reporting. That is certainly an earthquake uptick, and keep in mind, folks, any earthquake can be a foreshock. If we were able to actually forecast earthquakes, we would jump at the opportunity to do it. I'm just not convinced that any of the forecasting works, except for things like statistical analysis. Also, last on the list is a 5.3 at Palu, Indonesia at 10:09 Universal Time this morning. I would also note continued minor activity there near the Cascadia fault zone. Anyway, moving back to space. Thinking about moving off of planet Earth into space. What do you think? Let us know in the comments. There's another 24-hour video from SDO, the Solar Dynamics Observatory. And let's move on to some space weather statistics. The 10.7 centimeter radial flux is now at 176 solar flux units. A little uptick there since yesterday. I think it was at 171. There is the 1-year graph. To put it in context, it's this black line. You may notice an upward trend since we are not yet at solar maximum. If you want to view that graph yourself, it's at solon.info. Next, NASA's forecast for the coronal mass ejection associated with that X-class solar flare. And there you can see it just brushing past Earth. So Earth is this yellow circle right here. And you'll see a minor impact there possible on the 8th. Yeah, on the 8th. It's fast moving. So the dense core will not be striking Earth, most likely. It is well off to the west. But there could be some significant ejecta striking Earth. NASA wants to forecast that. They've got skin in the game, namely astronauts in space. So it looks like early in the day on the 8th. NASA and NOAA largely agree there. There will be some CME impact from that coronal mass ejection. Again, the one associated with that X-class flare that you'll be hearing about all over the internet all day, nonstop, from all the space weather types. Should be interesting. And if you read NOAA's forecast on the Space Weather Enthusiast dashboard, indeed around, it looks like around midday, they're expelled, I guess must be around between 3 and 6 universal time, so early in the day on the 8th. I would tend to agree, again, that is a high speed, higher than normal speed coronal mass ejection. And that is a Space Weather Enthusiast dashboard. Now, after that, we usually show the Geospace Magnetosphere movies. And check out the Geospace Magnetosphere movie. It's because of probably erroneous data there from the, I believe it's from the ACE spacecraft. The magnetohydrodynamic pressure is non-existent. So it's showing an extremely low pressure and extremely low density environment. Again, probably because of some sort of erroneous readings from that spacecraft at Lagrangian point 1. So there's the pressure. That is, there's the density. It's showing low density in white and high density in blue. And what it's showing is that there's no plasma, almost no plasma around planet Earth. A dubious claim indeed. So there is that, again, likely erroneous reading there. That's the Geospace Magnetosphere movie for the past 4 hours. And as far as the ground magnetic perturbations map, that's looking a little bit more believable, wouldn't you say? So this is Earth's magnetic moment from the ground, and we're going to show you why that happens here in just a moment. It has to do with the way the space weather modeling framework is generated. So at the moment here, nothing significant. Again, we are expecting possible geomagnetic storm conditions once again on the 8th. So that should be pretty sweet. It will be happening around it will be happening starting at least in daytime for the US, so that's not optimal for viewing aurora on this side of the planet. Current KP index is at 1. And here's what we're talking about with erroneous readings. So if you've never checked out the RealTime solar wind page, if you click on series, it'll bring up this screen. And if you leave it on active spacecraft, if only one spacecraft is returning the data, it'll show that spacecraft. Otherwise, it'll show both, the ACE and Discover. And if you're not pleased with what it's showing because it looks erroneous, then you can switch to the other spacecraft. So those are both located at Lagrangian point 1, about 1 million miles toward the sun from the Earth. And check out the readings here. 1/10 of a proton per cubic centimeter is the solar wind speed currently shown. So that's extremely diffuse. Let's see if indeed. So that, and by the way, this bar at the bottom is showing that it's the ACE spacecraft. They ought to switch to the Discover, but you can switch it yourself like this. So this is showing a more believable solar wind density at around 6 protons per cubic centimeter. Solar wind speed here, 478 kilometers per second. So that's what's going on with the solar wind. GOES magnetometers here in a very tight range. Not a lot of variation there in the GOES magnetometers. So that is the past 3 days following the subsiding of that unexpected by some, and when I say some, I mean people who don't view our channel, was that KP7 event. By the way, the KP 6.67 is exactly what we forecasted. You can see the live premiere chat from that day when it was stated in so many words. Here's a great example of how the magnetic environment can change suddenly with absolutely no warning. It is our top view ecliptic plane field plot. So Earth has suddenly snapped into a south pole current sheet. And there was no way I was going to forecast that. It's a prime example of how magnetism can suddenly shift. And indeed it has. So Earth is now in a south pole current sheet. You can expect Earth to remain in the South Pole current sheet here for an extended period, as that is a lengthy current sheet. Just keep in mind that, again, the magnetic environment can change with basically zero warning. Here's our line of sight field plot depicting the solar B field in blue, solar polar fields in red for south and green for north. And of course, the grayscale is the gong magnetogram. So still plenty of active regions on the Earth-facing portion of the solar disk. Here's our line-of-sight coronal hole plot. And right up here, that magnetic tug-of-war, it looks like it was won by the South Pole. There you go. South Pole fields there showing up. And here is the past 24 hours. That is SDO 211 angstroms. So looking back here briefly. All right, so there's the sector boundary crossing. Sector boundary crossing is going like this. These are North Pole coronal holes, and these are South Pole coronal holes. Very well defined there. There's a 24-hour video. And once again, there is the current line-of-sight coronal hole plot, which brings us to sunspots. So this is depicting yesterday plus today. Just hang on just one moment, folks. Here is yesterday plus today. That is SDO continuum. And we'll zoom in to show those sunspots. Oh, check it out. A new sunspot did form up here in the north. So there is one new group. Also another group formed right here. All right, so that's what happens when you are exhaustive in your analysis of the data. You might find things you didn't otherwise see. So let's take a look at the flare monitoring system. There is our solar flare probability scoreboard. And we still do have a significant possibility of large flares, especially from, let's stop that, especially from this group over here. It's still setting on the western limb there. It still has the capability of producing large flares, perhaps. The next possible place to see a large flare would be here. And then 3392 also. Looks like it's got significant magnetic shear. We'll show high-res images of that before we get to our meteorology segment. Here is a zoom-in of the solar equator. So really there are three places where we could see significant flares, mainly these three sunspots up here. That is 1600 plus 1700 angstroms from the SDO. And you see a lot of ionized carbon appearing right here around when that solar flare occurred. Lattice confined fusion, anyone? All right, continuing on. It's time to move on to energetic particles and solar flares. As far as energetic particles go, there was no energetic particle event associated with that solar flare unless it was very brief. It doesn't look like it was. Well, maybe it was. Looks like a second spike there, but it was pretty minor. It never got up to where it was, or very close. So if that was a solar energetic particle event from that CME and solar flare event, it was minor, and it has since subsided. So it's continued to subside here. No big deal on the GOES proton flux. And there's that X-class flare. Let's bring up the one-day graph. Peak flux was around 2222. That's around when peak flux was. And strap in, or strap on your strap-on, or whatever, because here comes some absolutely incredible images of the closest star. Our solar flare section today ought to be viewed far and wide. We have no expectations. So here's a little close-up. That's 131 angstroms from SDO. A 3-hour video at 15 frames per second. DAG. To quote Lance Armstrong, how about them effing apples? We let it play through twice. The rest of these are only going to play through once. If you want to watch them again, you'll have to go back and watch this same video. Here's 94 angstroms. The same area, the same frame rate. A different species of ionized iron. 94 angstroms. It's the extreme ultraviolet emissions from hot ionized iron gas. There's a lot of iron where you see that white. Here's a slightly zoomed out view featuring 131 plus 94 angstroms. And here's 304 angstroms by itself. This might actually be the best wavelength of all. And while it doesn't take as many frames as 94 and 131 angstroms, it does show plasma filament features quite a bit better. It is ionized helium, 304 angstroms. And that, my friends, foes, and neutrals, is some pretty sweet imagery. We'll get to solar flares, coronal mass ejections here in a moment. First, take a moment to orient yourself. Do you know what's going on above your head? Well, one of the ways you can figure it out is with skyandtelescope.org's great sky chart. We are not affiliated in any official capacity with skyandtelescope.org, but I just like their star chart, so I show it to our viewers on the regs. If you're viewing the post-sunset sky, you might see Venus, as well as Mercury and Mars up there near the ecliptic, as the gibbous waning moon sets in front of Jupiter over Lehigh Valley, Pennsylvania. Here comes your solar system forecast. This is today's situation. We'll advance this 1 week. Some people might be frightened of Saturn, the Earth, Mercury, and Mars and Venus all being in a straight line. I don't know why. That is ridiculous. No, the planets aren't going to kill you. No, the planets do not control solar activity. No, planetary alignments do not cause earthquakes. Just stop with that ridiculous nonsense. It's embarrassing. Today's astronomy picture of the day isn't embarrassing at all. It's just totally sweet. Check this out. It is a giant plasma filament. That is from supernova 1006, a supernova which appeared in the year 1006. And it also featured a star that got so bright that it looked like Venus for a couple of years. Approximately as bright as Venus for a couple of years. So it's just this huge filament, part of that supernova remnant. There's the full view of that from the Hubble Space Telescope. And if you want to see the full supernova remnant, that's not it. There it is. There's the full remnant. And interestingly enough, there's still a star shining in the middle of that supernova. So one of the most violent explosions ever witnessed by ancient humans in the year 1006. Supernova 1006, folks. A light that became as bright as Venus. Now, unfortunately, the George Mason University coronagraphs here are lacking data. So yesterday's coronagraphs are weak. It's only 83 frames, and it's not even showing the latest Earth-directed CME. So that's unfortunate, but that's okay, because check it out. The regular LASCO coronagraph page indeed does show it. So if you bring this back to early this morning, almost first thing this morning, you can see a halo. So most of the ejecta there is expected to miss to the west, I would agree. However, some of that there is indeed likely to strike Earth. Now, it could be two separate events. I suspect that it might be, and we'll show you why here in a moment. First, we'll look at stereo A, which unfortunately is also lacking some data. So 1900, and then, whoops, 2353. So that's not helpful. And let's move to our custom coronagraphs, because this shows more than we need to show. So there's another 24-hour video. You've got SDO 304 angstroms ionized helium in the center, SOHO LASCO C2 in red, SOHO LASCO C3 in blue. Let's get a little bit closer. So again, there are two separate events here. One is from this. You'll see right in here a CME happening. A little bit of limb darkening right there. And it occurs after this one. So it looks like it's moving up to the northwest, but it actually appears to come out of the... All right, I stand corrected. That is not... Okay, so that one did come out of the... Actually came out of the northwest. So here's an even closer view of that. You'll see right down here, there is a CME right there. And so that's a separate event that we'll miss. So this X-class flare associated coronal mass ejection will brush past Earth. There could be a very strong magnetic field with a plasma cloud that huge and with that dense of a core, so we'll have to see what happens. Could see as high as a KP 6.33 or something from that. NOAA forecasting a KP 5. And here's just 304 angstroms by itself. A great wavelength to view various solar features. It does show coronal holes. It shows active regions, obviously. It's good at showing plasma filaments and prominences. It even shows flares fairly well. 304 angstroms, a classic. Wavelength in extreme ultraviolet light. So let's get to filaments next, because there are still a very large number of filaments on the Earth-facing portion of the solar disk. The likelihood of additional coronal mass ejections is 100%. Some of those filaments will eject in the next 24 hours. Don't believe me? Well, watch tomorrow's daily space weather video. We'll show you the CMEs that occur. That's the El Teide, Spain ground-based solar observatory. And you know, we didn't formally show this because it doesn't show the edge. This shows prominences. The other one doesn't. We knew about it the whole time. It's just that, well, because the next frame is so visually spectacular, we've picked it up. So there's the same observatory. Lots of dense absorption features there, known as plasma filaments. Expect coronal mass ejections to continue. I guarantee it. So here's the past 24 hours from SDO 193 angstroms, another great wavelength for showing various different features. It shows the extended corona. It is also good at showing active regions, coronal holes, and plasma filaments. Not quite as good at showing solar flares as 304 angstroms. 193 angstroms is one of the many species of ionized irons, extreme ultraviolet. Photonic emissions. Once again, folks, don't confuse solar flares and coronal mass ejections. They are separate events. Coronal mass ejections are protons, and solar flares are photons in the form of X-rays. If you want to name filaments after living people, we highly recommend it. There are several there that could get names, especially this one. This is a very, very large and dense filament, and it is still intact. So that one could certainly use a name. Let's actually demonstrate how to do this on the platform formerly known as Twitter. Just follow the hashtag #NameThatFilament. I can't spell today. Name that filament after living people. Over on the platform, brilliantly rebranded to X, pardon my sarcasm. So we'll close out the space weather video with our bonus features segment. Here is the past 24 hours, the past about 2.5 hours from the GOES 16 SUVI. And you can see there is still considerable instability going on over here in the northwestern limb. Don't be surprised to see more high-level flaring activity. So far, this new active region in the east does not appear to be a sunspot, but there appears to be some more active regions rising in the east. The next of our bonus features is satellite charging hazards. We don't have any. It's smooth sailing at the moment for satellites. Here's your GOES Electron Flux at very low levels. These are erroneous readings, by the way. So if you read the Details tab, it'll explain all about that on the GOES Electron Flux. This happens when the ionosphere puffs up, because keep in mind the GOES 16 and the GOES 18, they're measuring the electron flux at the F layer of the ionosphere. So they're calibrated for that layer, and when the ionosphere moves, they're still measuring it at that layer, and hence you get an erroneous reading. So here is the 1-year graph to put all of that in context. Here is the forecast model. And these forecasts might be wildly incorrect. I won't even make any conjecture as to what will happen next with the electron flux, but we will show you the layer of the ionosphere where it's measured, as we've got major ionospheric anomalies happening. Feel free to pause the video in this frame. Yowzers. Lots of low-frequency anomalies happening in the ionosphere. So there'll be huge vertical variations happening here. Very diffuse material and very dense material close to each other in the ionosphere. In other words, the ionosphere is lumpy and parts of it are puffy. I'll just say that. And we've got to blast through this video here. This video is getting lengthy because we've had so many fantastic series of images of solar flare. So here's the anomalogram. You can see lots of red showing up here as forecast. It's just a matter of understanding the physics, folks. You can forecast your Earth weather, and if you watch our channel, you can probably even forecast your space weather. Impress your friends and foes by forecasting space weather. Wow, major low-frequency anomalies here dominating the ionosphere as we forecasted. That is anomaly in megahertz from a 30-day median. And here's the latest image. That's 12 o'clock universal time, 12 noon UT. And there is the anomalogram. We also show total electron content. It certainly helps to forecast where GPS errors are most likely. There is the world view for total electron content. It's free electrons from about 12,500 miles of altitude, the inner portion of the outer Van Allen belt, down to your handset. So things are actually pretty organized here. So I would tend to say that the electron flux is going to rise before that CME impact happens. Let us know in the comments if you've got a different forecast. Next, the total electron content anomaly from the 10-day average over North America. We are seeing continued high electron content anomalies here over around Vancouver. So that's been going on for days. We'll close out the space weather portion of this video with the latest high-res images of the closest star. Stargazing. Learn how the closest star works before you're concerned about what's going on in the cores of distant galaxies. So there's a new sunspot as well. So we could have as many as 3 new named sunspot groups today. As far as the rest of these active regions here around the eastern limb, it looks like only 1 new region there. A little bit of growth in the trailing umbrae here. Once again, the most likely place to see a large flare remains certainly in this area right here. There's your full disk rock back. And let's move to meteorology. The first thing we're doing is we're going wave hunting. Yeah, wave hunting. I'm a wave hunter. I'm always interested in where the planet's largest waves are. And here's where they are. They're in the central Pacific Ocean here. Not a lot of people around there. 45.5 footers out there. That is not a place to be on an outrigger boat trying to row across the Pacific. 45.5 foot waves are pretty bulky. We also do have some major waves in the southern Atlantic there. But yeah, certainly the biggest waves are in this area. And we are approaching hurricane force winds. There probably are hurricane force winds there. This nullschool.net imagery is not super accurate at getting the highest wind speeds that you'll find. We'll let it slide because it is such a fantastic application. Nullschool.net. Shout out to nullschool.net. Just a fantastic website there. We highly recommend it here at the Smash News Network. Least busted name in news. Here's the rest of your meteorology stuff. There are the surface winds of the eastern world. Here are the jet streams of the east. Here are the jet streams of the west. Here are the surface winds of the west. Surface winds of the central world. And shout out to our viewers from all around the planet. We remain surprised that you've found the channel. Here are the jet streams of the central world. And here's a satellite image of the lower 48. As the sun rises across the Mississippi Valley, there is a strong system there around Missouri once again. Missouri, Oklahoma, Kansas, and Arkansas. Seeing some significant systems. Also some rapid cloud nucleation happening here in Tennessee, where it looks kind of moist. Also South Dakota featuring some large cloud cover. Here's clouds and fog in shortwave radiation. I had to make sure I wasn't overlapping the map. There we are. Shortwave radiation over the Americas, depicting clouds and fog when it's too dark for the visible satellite. Here is our smoke map forecast by firesmoke.ca. And Washington, heavy smoke in Washington. By the way, I smelt burning wood yesterday. I smelled it. I went outside and it smelled like a campfire. I think it might have been from a local event, actually. Not from Canadian smoke, but I was like, oh, sweet. Is it getting smoky again? Well, not really. Not in the mid-Atlantic states. And if you're wondering where we're located, we are right about here. About an hour from New York and Philadelphia. Right about there in Lehigh Valley, Pennsylvania. One of the best cycling communities in the whole world, by the way. If you're considering a cycling vacation, consider Lehigh Valley, Pennsylvania, the home of T-Town. One of the most significant world-class cycling communities in the entire world. Here's our weather.gov map to briefly show you a lot of heat warnings there. A lot of excessive heat around the Gulf Coast. Weather.gov. Looks like some tropical storm warnings there on the west coast of Mexico. Here come some forecasts. There is the GFS 72-hour total accumulated precipitation forecast. Some significant flooding here in the forecast for Pennsylvania and also New England, mainly Maine. And also some isolated areas then in Iowa and Illinois. Also Georgia, going to get some significant rains. Here's your 72-hour pressure and precipitation forecast. Some heavy weather here coming to the southern Great Lakes states, the southeastern U.S., and indeed the mid-Atlantic. GFS temperature anomaly forecast in degrees Celsius depicted here. And let's don't forget the jet stream forecast. Once again, the 72-hour GFS jet stream forecast. Brought to you by TropicalTidbits.com and hosted by the Smash News Network, least busted name in news. Here's your lightning mapper. That's the past about 10.5 hours of lightning. That's where the strikes have been. Let's see where the strikes are while we produce this video at lightningmaps.org. We indeed do have some terrestrial strikes here around the Tennessee, Georgia, and Tennessee, Alabama borders. Also around the Arkansas-Texas border. Some minor active cells showing up there. It's pretty chill as far as lightning goes at the moment. By the way, if you enjoy the content and you'd like additional content, consider becoming a member of the Smash Team at smashamash.com/SmashTeam. It is the official subscription services site of this channel. You'll get the most benefits, the most additional content by being a Gold Smash Team member. There's also a silver level and a bronze level, and we send out email alerts and so on. I feel like a broken record saying this. If you're not getting notifications from certain video hosting platforms, then sign up for a bronze Smash Team level membership. It's free, and you'll get notifications when we put up videos and other content. SmashOmash.com/SmashTeam. Links below this video as well as on the homepage at SmashOmash.com. And welcome to the Neo Renaissance. Again, we are surprised that you found that the channel exists. We'll close out this video with U.S. Doppler radar for the full 50 states briefly, and then we'll focus on the lower 48. There is clouds and fog. Once again, shortwave radiation, 3.9 micrometers. Part of the infrared spectrum. And check it out, you've got a compression feature happening here. You've got dry mass of air over here and dry mass of air over here. This is acting like a blocking feature. This is acting like an impulse. And it's forcing a huge pressure gradient for that low pressure. Remember, folks, dry air is more massive at a given temperature and pressure than moist air because of the molecular mass of N2 versus H2O. Anyway, here is the recap U.S. Doppler radar, clouds and fog, and of course, water vapor. When your Doppler is unclear, the water vapor will clear it up especially if you understand atmospheric physics. Are you able to forecast your own weather? Are you able to forecast space weather? We empower our viewers instead of attempting to gaslight them. So, thanks for tuning in. I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news. And until next time, may that solar wind be at your back.